This is number 4 non-calculator of the AP review for derivative graphs, FRQ. So graph f prime is given to us. Our function f is differentiable, smooth curve, on the closed interval from -6 to 5 and satisfies the order pair -2 equals 7, f of -2 equals 7. The graph of f prime, which is the derivative, is shown, consists of a semicircle and 3 line segments. So 1, 2, 3. So if we're looking at the derivative graph, I like to label what I'm dealing with here. Anything above the x-axis represents where my original graph is going to resemble a positive slope. Anything that's below the x-axis represents where my original graph will have negative slope. Okay, so find the values of f of -6 and f of 5. So if I want to find f of -6, I'm going to be using this formula of any position I'm looking for. I'm going to have a starting position plus displacement. So if I want to find f of 5, I want to start at f of -2 because that's what information is provided for us. F of -2 plus the integral from -2 to 5 of f prime. So we know we have to involve the areas of these regions. So this is triangle, 1/2 base times height, so 1/2 4 times 2. We have a quarter circle here, so pi over 4. Radius is 2, so 2 squared is 4. 4 over 4 is 1 pi, but it's below the x-axis, so we have negative pi and negative pi here. And then 1/2 base times height, 1/2 3 times 2, which is 3. So the depth integral from -2 to 5 is going to be negative pi minus pi plus 3. And that's going to give us 10 minus 2 pi. Okay. To find f of -6, it's going to be f of -2 plus the integral from -2 to -6. Now, if we want to do integral from -2 to -6, we're kind of looking at this backwards. So I'm going to flip the bounds. So when I flip the bounds, I can therefore go from a smaller to a larger value. So -6 to -2, if we look at the graph here, -6 to -2 is going to have a region of 4, area of 4. So replace this with 4, but there's a negative in front, so 7 minus 4 is equal to 3. Okay. Okay, for part B, on what interval is our function f increasing? So our function is increasing when f prime is above the x-axis. So our f prime, our f is increasing whenever f prime is above the x-axis. So above the x-axis from -6 to -2, and then above the x-axis from 2 to 5. Because f prime is greater than 0. For part D, for each f double prime of -5 and f double prime of 3, find the value or explain why it doesn't exist. So if I want to find the second derivative at -5, so the second derivative at -5, that's just the slope, right? So we know the slope is going to exist at that point, so we just do changing y over changing x. I pick 2 points along this line. So 0 minus 2 divided by -2 minus -6. And that gives me -2 over 4, which is -1/2. The last part, find f double prime of 3. So f double prime of 3 is asking for the slope at 3, and the slope doesn't exist because we have a slope of a positive slope all of a sudden changing to a negative slope. So the slope doesn't exist, and also we can say because the limit of the slope, basically the limit as x approaches 3 from the left and from the right of our slope are not in agreement. One slope is 2, the other slope is -1, so therefore f double prime of 3 does not exist.